In this video, I will tell you all about the functional area power reliability. The issue is how to safely and reliably supply the components of the charging station with power and protect them from failure. These components are found in the functional areas charge, control and monitor, and network and communicate. First, the charging station is connected to the grid. Details are described in the functional area connectivity. Of course, it is important to protect the charging station against overvoltages, whether as a result of lightning strikes or other overvoltage incidents such as switching operations in the grid. Such incidents can damage the connected electrical components through to the vehicle. Our optimal surge protection for this purpose is CHARX Protect. It ensures a secure and uninterrupted charging process even if there are overvoltages in the grid. This surge protection is designed especially for charging stations. Thanks to its pluggable modules, it is quick and easy to maintain in case of an error. Combined lightning current and surge protective devices, so-called combined type 1 and 2 arresters, can disconnect up to 50 kA. Simple type 2 arresters up to 40 kA are sufficient for home chargers. Downstream of the surge protection, the supply branches off. One side supplies the functional area charge. Another path supplies the charging controller and other internal components with 12 or 24 volt DC via the power supply unit. In most cases, our step power supplies are used, which are available in different power classes. They were developed and tested in accordance with the International Charging Station Standard. Functional scope and price level are designed to meet the requirements of the charging infrastructure. Additional redundancy or UPS systems are not necessary since the charging controller has an energy buffer to store relevant data if the primary power supply is interrupted. A secondary device protection is needed to protect all components like cables and the charging controller against internal short circuits and other errors. In a home charger, the risk of such errors is rather low due to the lower power levels, so that a device protection is normally not used. In charging stations, additional components and higher loads are added, which increases the need for a device protection. A thermomagnetic device circuit breaker is the optimal solution here, as it can be easily reset after tripping. Therefore, it supports a high availability of the charging point. It is also possible to create an inexpensive, space-saving combination of a fuse terminal block and a thermal miniature circuit breaker, which can also be reset. This combination also makes it possible to easily retrofit existing charging stations with vehicle flat type fuses thanks to the identical plug configuration. Phoenix Contact also offers solutions for integrated load and charging management. Firstly, these include an overlaid current measurement at the feeding point, including generators such as solar systems. Secondly, they also integrate loads such as household appliances and, of course, the home charger. However, charging and load management is much more typical in large, complex charging parks where much higher power levels have to be provided and distributed. With an optional energy monitoring of three-phase grid, the load on a circuit can be measured. The higher level controller in a charging park uses the measured data to conduct the load management. This ensures optimal usage of the available connected power and at the same time protects the grid connection from overload. For this application, Phoenix Contact offers a huge portfolio consisting of current, transformers and energy measuring devices. How charge and load management works in detail is explained in the functional area Control and Monitor. In conclusion, Phoenix Contact delivers comprehensive solutions for reliably supplying and protecting your charging stations.